Thanks everybody for coming despite these huge lines for lunch. I hope you've managed to eat something or that you will manage to eat. And yeah, welcome. So my name is Maciej Próchniak. I don't know if some of you or most of you were in my talk in the morning, but yeah, I'm Maciej Próchniak. I work for a software house called TouK. We're based in Warsaw, and today I'll be talking just a little bit about one of our projects that deals with stream processing for mobile operators and about the project that we've managed to develop in the meantime, right? So first let's talk a little bit about our domain, that's the mobile operator, and what kind of data do they have and what do we want to process fast in this kind of streaming way, right? So our basic events are our calls that you're making with phones, SMS events and stuff like that. And of course, they generate a lot of billing events, like, for example, how much they should charge you. If you have prepaid accounts, this is, of course, much more complicated because they have to do it in real time and so on and so forth. And of course, everybody is now using mobile phones for internet and stuff. So there are a lot of data concerning network usage, data transfers and so on. And also our phones are sending, in sometimes with each call and sometimes even every few seconds, some information to base transmitter stations so that well, the calls can be made and we can be located so that people can call us. And also there are, if we are customers of mobile operators, there are certain changes on our accounts. We can enable some data package, buy new tariff, and so on and so forth. Right? So how many events are there? Our basis is, well, large Polish mobile operators. As we all know, there are 4 of them. So the call, SMSs, billing events, and stuff like that, that's like few thousand per second each. So not so much. About network usage and localization, these things tend to vary because it depends what kind of data do we want to process, either kind of more pre-processed data or raw data, and they can even amount to, I would say, hundreds of thousands per sec. So this is kind of largest stream, and of course the account changes is negligible, right? Because how often do we want to change our accounts? So what do we do with this data? Well, there are 2 basic use cases, I would say. The first is fraud detection, for example, SIM cloning, various frauds concerned with premium usages and stuff like that. People are really innovative when it comes to, welcome, when it comes to, to frauds, both in telco, banking, and so on and so forth, but also real-time marketing. And again, people in marketing are also pretty innovative when it comes to defining various marketing campaigns. They want to change it really, really fast because the market is really saturated and competitive. And some basic analytics, online analytics that can be made, but we won't be handling those at the moment. Right? So, in fact, what is the challenge? Because all those data are currently processed by mobile operators, right? By their billing systems, which is the core business, to do, for example, real-time billing in prepaid accounts. So we want to process all those data as fast as in billing system, but on the other hand, we want to change our rules. How do we process them? As easy as, for example, writing SQLs in data warehouses. So, right? So analytics, marketing people can change them without touching billing system, which is kind of core and holy, and nobody wants to touch it without need, right? Because this is really critical. And stuff we want to do are not so critical. So this is the basic architecture, well, kind of generic architecture of a stream processing system. And just by coincidence, this is also architecture of our system. So there are some data sources like files, TCP sockets, HTTP logs, whatever. And we push all of them through Apache Kafka, which is by now, I think, like standard message bus for stream processing systems. And then we process it with Apache Flink, which is, I would say, the most advanced stream processing engine at the moment, even if Spark Streaming is competing nicely. We enrich the data with some kind of real-time customer profile because the events are pretty raw, and then we output some additional events. For example, we may block customer's account, we may send some SMS, we may generate some alerts for revenue assurance guys. And apart from that, we use our kind of secret sauce, which I'll tell you about in the moment. So how does working with Flink look like? First, there's the developer. He writes the code, or she puts it into the jar and deploys to kind of coordinator. This is called job manager, which then decides how to distribute the code, distribute the processing job for the workers, right? Because Flink is distributed processing engine, so there's kind of one coordinator and many, many workers, right? So this is how it more or less looks like. And the code looks like this, right? This is Scala DSL, pretty nice, pretty concise, quite easy to use, and for each developer, that is more than enough. Now, the thing is, we developers, don't want to write all those processing jobs, right? We want analysts, business people, revenue assurance guys to take care of them, right? We don't want to understand those marketing campaigns. We don't want to understand those fraud detection schemes. They are too complex for us, right? So how do we do it? Because, of course, they probably would understand after a while what this code does, but to write it, to deploy it, no way. And this is why we created our open source project Nussknacker, which is basically kind of user interface and some additional components that let user design, deploy, test, and so on, processes on Flink, right? This is something that we use kind of in daily jobs, and it's also open source, so I can show you that today. And when we developed it, we had like 3 main assumptions. So first of all, we thought that, okay, some parts of the system, like integration with various different components, should be written by us, developers, in normal code, right? This is something that business people or analysts shouldn't touch. They should only, for example, configure how to get some additional data and stuff like that. But they have to be able to express some business rules, like expression, for example, some thresholds for detecting frauds, or some conditions for marketing campaigns. They should be able to express it if they know more or less SQL, right? This is kind of popular demand, right? If you're an analyst, you probably know more or less SQL because you have to deal with various warehouses and stuff like that. And we want to make sure that it's easy for them to test and experiment, right? Because we don't want them only to design processes. We want for them to be able to handle the whole development lifecycle, right? So first, they probably design some marketing campaign based on some batch SQL warehouse SQLs. Then we want them to design the process, then be able to test it, deploy into some kind of user acceptance test environment. Then we want them to have courage to push deploy button and deploy the stuff to production, and then, of course, give us some data to close the feedback loop, right? This is something that everybody in whole big data, machine learning and stuff, business wants to achieve, and we wanted to try to achieve this at our field, at stream processing stuff with Flink, right? So this is something, yeah, I would say that we are currently making, achieving, and so on. Okay, so now let's have a try at the demo. Can you see it more or less? I mean, the screen is not so perfect, but let's try. So I don't have some sample from telco, but I have sample more or less from banking. But it's similar kind of fraud detection. Let's try to detect, given a stream of card transaction and the list of terminals, ATMs, to detect that somebody cloned your credit card, right? So we want to detect that in one moment you take money from ATM, for example, in Warsaw, and in the next 5 minutes, the same card is used to withdraw money, for example, in Szczecin, right? This cannot happen in 5 minutes without some fraud, right? And this is kind of real use case, real banks and telco companies are doing this. So let's look how would we do it in Nussknacker, right? So first we have a list of processes. I have prepared my own. Let's go back in the history of versioning because I'm not so confident to do it everything live, right? So first we take some data source, right? This is kind of some generic model without too much coding. You would just download it from when we release the release from our page and so on. So we take the data from Kafka topic that's called transaction. We define that there are fields like customer ID, amount, credit card number, and ID of the terminal. This is the important stuff. And then at the beginning, we send everything to some kind of alert, right? And this is great to begin with. Let's test it, right? So here, I'll show you here. This is my test file, right? I prepared some test data, and some analysts can do it. And now I deploy the process in some kind of, this is kind of sandbox Flink cluster that's running inside our application. But we can see something, right? We can see the types of the data and so on, how the alert would look like, and so on. And then we can define further functionalities. I'll hide this. Now our process now looks a little bit more elaborate because here we are introducing some data enrichment, right? In our source, we don't have, for example, the exact location of the ATM, right? Let's imagine that we have some REST service. Of course, I have CSV file with list of all ATMs and their locations. Okay, so I prepared such service, and then I would do something like that: drag, drop, and my business analyst would just have to declare what is the ID of the terminal, right? So now we have the input. He can then choose which field to use as the ID of the terminal, and voila! Here we can define also some variable with output, and here we can use additional variable that is called terminal, and see its location. That's the latitude and longitude. Here we use some real data from real banking system, right? And so on and so forth. Yeah, I want to discard changes. But then, this is a kind of simple filtering, simple enrichment. But we also have some predefined stateful operators, right? Because Flink is mainly used for stateful stream processing. So for example, here, we want to be able to see the previous transaction for this account, right? This is something like Flink does for us. I still don't know how much time do I have, but nevertheless. So again, this is kind of ready to use block. We just have to configure it. For example, what is the key of our aggregation? This time we just compute previous value, and so on. And then, again, we can use this additional variable, that's the previous transaction, that is computed by Flink, to, for example, use some custom-made functions to compute the distance between our current transaction for this customer and the previous transaction that is handled statefully by Flink, right? So when we compute the distance, we can compute also the time difference and so on. And of course, we want to do the filtering, right? Here we have some additional variable. When we divide the distance of transactions and the time in minutes, and we get the velocity. So now we can filter out these transactions that occur too fast and too far away from previous transaction of this customer, right? This is more or less the whole process, right? This is more or less the whole process. I can try to test it on some simple data. And let's see what happens. And, okay, here we have sorry about that. Here we have 4 transactions at this step from our test data. And here we have only 2. And we see that in our input data we have 1 suspicious transaction. So we are more or less sure that this process kind of works, right? What we did was essentially kind of a little bit like unit testing, like sandbox testing, not really unit testing, but for data analysis, this is kind of okay. Now, let's try to do something scary. Let's deploy it on real Flink cluster. I have one on my laptop, surprisingly. So normally the analyst would do it on kind of, and I'll generate some data, fake data because I prepared it. So normally this would happen on some kind of user acceptance test cluster, right? we would then generate some real stream of production data, clone it to user acceptance test environment. Now the analytic would deploy it to user acceptance test environment, leave it for like 2 days, and he or she would see what happens, right? If the process meets the criteria. Of course, no accounts would be blocked, no real-time, no production alerts would be generated, but still, they would be able to see something. When we deploy the process on real Flink cluster, we have some predefined metrics so we can see what is going on. This is pretty cool because it's easy to generate such a dashboard for each process with Grafana. And we can see that, yeah, there are pretty large amount of transactions. I don't know if you can see it, but it's like 45,000 transactions per second that we process with our process. So for those of you who sit in front, they can hear my laptop going a little bit heated. So we process right now like 40,000 transactions per second, and we can see that some of the events get rejected. For example, here, some ATMs have bad IDs. We filter them out. Here, most of the events are filtered out because they are not fraud transactions. But some transactions, like 1/10 of them per second, they generate real alerts. And somebody from my company prepared a demo when you can see that really this is happening, right? This is kind of simple React applications that we can see that these are transactions for, I think, from last minute. And we can see that we detect that 2 transactions for the same account occurred in Rzeszów and somewhere near Torun, right? So this is kind of course, the real use case would be something more elaborate. But this is kind of a base that our analysts do to detect frauds. Of course, they have more elaborate business conditions. And then after a while, when they test it, they're kind of mostly confident enough to deploy this stuff in production. Of course, this needs our assistance, monitoring, and stuff, but most of the cases are handled by themselves. Okay, I think the time is up. So that's the last slide. It's on a GitHub. You can try it out. Of course, we have to do some additional documentation, stuff like that. But this is what we use generally right now in production. If you have any questions, I will be here around. And if not, then enjoy your lunch or rest of the conference. Yeah? Great question. Because Flink is better. Well, essentially 2 years ago when we started, Kafka streams didn't exist, and Spark streaming were kind of far inferior to Flink in terms of, for example, complex state processing, windowing API, and so on. So, Spark streaming is much more popular, so it gains traction and stuff like that, but they're still a little bit behind in terms, for example, kind of latency and stuff like that. Only in latest release they started to do some kind of real-time processing and not micro-batching and so on. And Kafka Streams is kind of more suited to be embedded into applications, right? But I don't know. Maybe in the future we will have also versions that works in those environments. Any more questions? Then thank you very much for coming and enjoy.